Jai Bharat to all students. In last lecture, we have started a conditional probability, which will directly dependent event. Okay. In that last lecture, we have discussed how to solve conditional probability and 2 or 3 example related to them. Okay. So now in that lecture, we will discuss more about some difficult example related to the conditional probability. Okay. And also if this condition probability have till now we have only discussed about 2 event. Yes, P of A multiplied by P of, if it is a B event per A event. Okay, P of B per A. 2 event are there, A and B. Now let's say there are 3 event or 4 event. Okay, so then how can we solve probability? How can we find probability? Okay, that also we will discuss in this lecture. Okay, so condition probability, dependent and independent, we already know. A dependent event, okay, if it is a with displacement, it's independent. If it is a without displacement, it's dependent. Okay, now this like equation is important. P A and B is equal to P of A into P of B per A. Okay, for independent we have equation has, if it is independent, then P of A multiplied by P of B. Okay, equation formula is same, but notation is different for independent and dependent event. Okay, only notation is a different. Okay. Okay, so this soccer game also, this example also we have discussed in basic of different types of event. Okay, so you are off to a soccer and want to a goalkeeper. Okay, but that depends on who is the coach today. Okay, with coach Sam, the probability of being goalkeeper is 0.5, and coach Alex, probability of being goalkeeper is 0.3. This example also we have discussed in previous, but then in that lecture we only discuss this is dependent event. Okay, we do not solve how many probability. Okay, so in that lecture, in this lecture we will discuss. So what is the probability that you will be goalkeeper today? Okay, you have to find the probability being the goalkeeper. Okay, in that we have solved the tree diagram also. Okay, if it is a coach Sam, 6 out of 10, Sam is coming today is the probability of 0.6, Alex is come is the 0.4 today. Who is the coach is depend on the this probability 0.6 and 0.4. Okay, so now if Sam is come, there is a 0.5 probability that you being goalie. Okay, this 0.5 is given in the question. Okay, so coach Sam is a coach today, so there is a 0.5 percentage probability, 50% probability that you will being goalie. 0.5 and no is point also 5. Okay, why? Because total summation will become 1. If you get Alex as a coach today, there is 0.3 probability. Yes, already given in question. So if there is a 0.3 probability of being goalie, then 0.7 probability you will not become goalie. Okay, so now we have to calculate that I will be goalie. Yes, what is the probability that you will be goalkeeper today? Okay, so now yes, so for take a one path, Sam and yes. Okay, so there will be a, this is P of A point, and this is, it's depend on the other, so P of B per A. Yes, this 0.5 will noted as a P of B per A, and its a probability is 0.6 multiplied by 5 is equal to 0.3. Also, there is also probability that you will choose from LX. Okay, so this also will going to be yes. So 0.4 into 0.3 is equal to 0.12. Okay, so now we have two chances. So generally we have to add them. Okay, so there is a 0.42 probability you being goalkeeper today. 42% chances. Okay, you have to count only yes. Yes, same probability of Sam will coach today and probability of you being chosen. Probability of Alex will be coached today and probability of you being chosen. Okay, so 0.4 into 0.3, 0.12. Okay, we have now two probability that only you will choose. So we have to just add them. Yes. Now if you check all the probability, yes, no, 0.6 into 0.5, 0.6 into 0.5, 0.4 into 0.3, 0.4 into 0.7, and if we add all of that event, probability will make 1. Okay, so there our answer is right. Okay, all the event probability of all the event will be always become 0. Yes. Okay, now next question. There are 4 friends: Alex, Black, Krish, and Dusty. Okay, each choose a random number between 1 and 5. Each choose a random number between 1 and 5. What is the chance that any of them choose the same number? What is the chance that any of them choose the same number? Okay, like say Alex choose 2, Black choose 1, Chris again choose 2, and Dusty choose 3. So this is the same number. Okay, so we have to find out the probability of being choose the same number. Okay. Okay, so choosing the same number, if Alex choose 2 and Chris choose the 2, then you can see that for the probability this has to happen, it will depend on the previous outcome. Why? Because if Alex choose the 4 and none of them choose the 4 number, then it will not become same number. Okay, for the same number it will have to depend on the what other person is choosing the number. Yes, right, so it will depend on the other person. Okay, if for number one they select 1 2 3 4, so this is not the same number. Okay, for the same number they have to depend on the others person number. Here dust if say Dusty has to choose 1 2 3 any number. Okay, if we choose 1, that it will depend upon Alex. If we choose 2, then it will have to depend on Black, so that same number is will arise. Okay, so this same number is a question of dependent event. Yes. Okay, now let's make a tree diagram. Okay, first we take 2%, Alex and Black first. Okay, have the same number. Okay, how we'll going to compare the same number. Okay, so now first of all, if Alex choose from 1 to 5, 1 2 3 4 5, any number, what is the probability? 1 upon 5. Yes. Yes, and also Black also have to choose from that number. Okay, so for the same number there is a probability is 1 by 5. Okay, both have to choose the same number. And if let's example suppose Alex choose 3 number and Black again now have how many numbers available to choose from 5, and which they Black choose 4. Okay, so this is not a same number. For the same number, to find the years, both of them have to choose same number. Okay, so there is a how many probability, how many chances are there? You both of them can choose only one number. Let's assume they have choose 3 number, so there is a total number 5, and they have choose, both of them choose 3, so there is a 1 by 5 probability that it will have, both of them have same number. Okay, and 4 by 5 of no. Yes, why? Because there is a if Alex choose 3, then black have 4 number to choose, that it will have, both of them have not same number. Okay, yes, Alex can choose from 1 to 4 5 for the both of them have not the same number, no probability. Okay, so 4 by 5. Okay, now you can see that yes and no make together 1. Okay, now let's execute third person Chris. Okay, here for the no, if it is a yes, then our probability will be choose the same number. Yes, so now no, here Alex choose 3 and black choose any of the number, like let's say 1. Here Alex choose 1 number. Okay, now if we add here Chris, okay, so Chris had to choose from 5 number. Okay, now what are the 5 numbers? Chris have to choose 1 2 3 4 5. Now if both of them have to be same number, here what are the same number? 1, and we also include 3. Yes, if it is a select 3, then Alex and Chris will become same number, same person of number. Okay, so there is a 2 by 5 probability. Yes, if it is a choose 1 or 3, it will become our same number probability. Yes, and other than 3 number are 2 4 and 5, so that 3 by 5 probability. Okay, let's assume Chris choose 4. Okay, or here for the yes, you can choose 1 or 3, anything. If it is a yes, then both number has the same, so our probability will be 4 by 5 multiplied by 2 by 5. Here for the no probability, our will become 4 by 5 into 3 by 5. Okay, is equal to 12 by 25. Okay, now we add 3%. Okay, now what are the name? Dusty. Okay, we have to add Dusty. Okay, here Alex choose 3 number, here black choose 1 number, and here 4 number. Okay, no, if we add Dusty, Dusty have how many number choose from? Again 5, 1 2 3 4 and 5. But here if we choose 1 3 or 4, these 3 number, then we can say that there is a same number person. Why? Because already Alex choose 3, black choose 1, and Chris choose 4 number. Okay, so there is a 3 number. If we choose from 1 3 or 4, then our yes choose the same number is yes, probability of same number. Okay, so there is a 3 by 5 probability. Okay, so then for the path we have to calculate how many probability? 4 by 5 multiply by 3 by 5 multiply by 3 by 5. Okay, yes, and for the no probability, there we have now remaining 2 number, 2 and 5, 2 by 5. So 4 by 5, 3 by 5 and 2 by 5. Okay, so how many yeses are there? These 3, and we have to add that. Okay, so this is our probability choosing the same number. So all friend, yes chances together make 101 upon 125. Okay, so this is a question. It's a somehow long but is easy one. Okay, but now let's our complement. I have in last to last lecture, I think I have studied you complement, probability of complement means P of A dash, in which what is the P of A dash? If we 1 minus P of A, then it will become our P of A dash. Okay, so now if we want to find out this problem for the probability of choosing the same number, but let's assume we first of all find out the probability of not same the number. Okay, so just we have to calculate only no. Okay, and we if we 1 minus no, then we can get the answer. Okay, so only we have to calculate. Okay, for first person, both of them have not the same answer, will be 4 by 5. Okay, then 3 by 5. Why? Because two number already chosen. Okay, then 2 by 5. Okay, so it will become 24 by 125. Okay, and if we difference be from 1, we get the answer 101 minus upon 125. Okay, so from this method also you can solve these types of example. Okay, okay, now let's start with the, if there is a two or more dependent event, then how can we find out the conditional probability. Okay, I have already told formula of both of the dependent and independent event. Okay, for dependent event only notation will be changed, formula of multiplication to event will be remain same. Okay, e2 is dependent on the event, here both of them independent event. Now let's assume there is a three dependent event. E1 E2 is dependent on E1, and E3 is dependent on both of E1 and E2. Okay, previous E3 will depend on the both of the previous outcome. Okay, so probability of E1 and E2 and E3 is equal to probability of E1 multiplied by probability of E2 is dependent on E1 multiplied by probability of E3 dependent on E1 and E2 both. Okay, E1 and E2 both. So this is the formula of three dependent event. Okay, now let's say there is a fourth event E4. So formula this will remain same, only multiply by probability of E4 per E1 and E2 and E3. Okay, okay, but in your syllabus there is a no for dependent event example on four depend, you only have asked the three dependent event. Okay, so this is the formula for the three dependent event. Okay, let's start with the example. Okay, this is a simple example of independent event, just we have to multiply. Okay, this is a again example of independent. Okay, this is example of, okay, two balls are drawn successively without replacement. Okay, without replacement means dependent, from a box which contain 4 white ball, 4 white and 3 red. Okay, find the probability that the first ball drawn is white and the second is red. First white, second red. Okay, so if we choose first white, okay, there is a total 7 ball, so probability will be 4 by 7. Now, and second red, there are only now 6 ball reps. Okay, and 3 are red. Okay, so probability of choosing red will become 3 by 6. Why? Because one ball we have choose white. Okay, and it noted down like this: P of E2 depends given probability of E1. Okay, so dependent event, so this will we have to multiply by 4 by 7 into multiply by 1 by 2 is equal to 2 by 7. Okay, now second they have asked both balls are red. Okay, so this is also a dependent event. Okay, so first ball we have choose what is the probability of red. So P of A1 is equal to red means 3 by 7. Yes, 3 red and 7 total ball. And what is the probability of second will be also so we have to write down notation like this. Yes, so now we have only 2 reds are left. Why? Because in probability even we have choose red ball, and also total number of ball are decrease 1, so 2 by 6. Yes, 1 by 3. Okay, so probability of both ball are red 3 by 7 multiply by 1 by 3. Here cancel 3, so it will become 1 by 7. Okay, so that's how we can calculate the dependent probability or conditional probability. Let's start with the 3 dependent. Okay, a bag contains 5 white marble, 3 black marble, 2 green marble. In each draw a marble is drawn from the bag and not replaced. Okay, not replaced means dependent. 3 draw. Okay, they have given 3 draw. Okay, so now we can say that there is a 3 event. Okay, so probability of obtaining white, black and green in that order. Okay, in first we have white ball, in second we have black ball, in third we have green. Okay, that's probability we have to calculate. Okay, so first of all probability of white. Yes, in the first draw will be 5 by 10. Yes, there is a total 10 number of marble, and white marble are 5. Then second black, it will depend on the first white. Yes, so we have to write down like this, B2 per W1. Yes, okay, now for black, how many blacks are there? 3, but we have choose one from this, so total number of marble remaining is 9 from in bag. Yes, then second green. Okay, green, if we choose green, all the previous outcome we have to depend. Okay, so green we have to write like this, in third draw green 3, it's depend on both of B2 and W1. Okay, now how many greens are there? 2. And how many marbles are remaining? 8, because one we will have choose from this and one we have choose from this. So in bag there is only 2 by 8 number of marble remain. Okay, so bus. Okay, now if we want to find out the probability of obtaining white, black and green, we have to multiply. Yes, 5 by 10 multiply by 3 by 9 multiply by 2 by 8, 1 by 24. There is a 1 by 24 probability that white, black and green are in that order probability. Okay, so if we give 3 event, we have to 3 dependent event, we have to solve like this. Okay, so now your condition this is your today's question. Okay, now your condition probabilities topic is completed. Okay, in next lecture we will start Bayes theorem, and after that we will start probability distribution, normal distribution. Okay, different types of distribution probability. Okay, so this is your assignment question. Write it down in your book and upload it in RNWIET application. Okay, so today's lecture is completed.